Hello, I am Barnali Saha. Today's topic is effect of exercise on respiration. We know that muscular exercise brings about a lot of changes on various systems of the body. Normal effects of exercise on respiration are increased demand for oxygen, increased rate of CO2 removal, gaseous exchange, increased depth of breathing, increased breathing rate, respiratory muscle get fitter and stronger, increase in lung volumes and capacity to breathe air, improved blood flow to upper lobes of lungs, improved utilization of the alveoli, increased in gaseous exchange, and etc. Effects of exercise on respiration depends on six terms. First, effect on pulmonary ventilation. Pulmonary ventilation is the amount of air that enters and leaves the lungs in 1 minute. It is the product of tidal volume and respiratory rate. It is about 6 liters per minute with a normal tidal volume of 500 ml and respiratory rate of 12 per minute. During exercise, hyperventilation occurs. In moderate exercise, respiratory rate increase to about 30 per minute and tidal volume increase to about 2000 ml. Thus, the pulmonary ventilation increase to about 60 liters per minute during moderate exercise. In severe muscular exercise, it rises still further up to 100 liters per minute. Factors increasing pulmonary ventilation during exercise: number 1, higher centers; number 2, chemoreceptor; number 3, proprioceptor; number 4, body temperature; number 5, acidosis. Next, effect on diffusing capacity for oxygen. Diffusing capacity for oxygen is about 21 ml per minute at resting condition. It rises to 45 to 50 ml per minute during moderate exercise because of increased blood flow through pulmonary capillaries. Number 3 is effect on consumption of oxygen. Oxygen consumed by the tissues, particularly the skeletal muscles, is greatly enhanced during exercise because of vasodilatation in muscles during exercise. More amount of blood flows through the muscle and more amount of oxygen diffuses into the muscle from blood. The amount of oxygen utilized by the muscles is directly proportional to the amount of oxygen available. Number 4 is effect on oxygen depth. Oxygen depth is the extra amount of oxygen required by the muscles during recovery from severe muscular exercise. After a period of severe muscular exercise, amount of oxygen consumed is greatly increased. Oxygen required is more than the quantity available to the muscle. This much of oxygen is required not only for the activity of the muscle but also for reversal of some metabolic processes such as: number 1, reformation of glucose from lactic acid accumulated during exercise. Number 2, resynthesis of ATP and creatine phosphate. Number 3, restoration of amount of oxygen dissociate from hemoglobin and myoglobin. Thus, for the above reversal phenomena, an extra amount of oxygen must be made available in the body after severe muscular exercise. Oxygen depth is about 6 times more than the amount of oxygen consumed under resting conditions. Number 5 is effect on VO2 max. VO2 max is the amount of oxygen consumed under maximal aerobic metabolism. It is the product of maximal cardiac output and maximal amount of oxygen consumed by the muscle. In a normal activity and healthy male, the VO2 max is 35 to 40 ml per kg body weight per minute. In females, it is 30 to 35 ml per kg body weight per minute. During exercise, VO2 max increased by 50%. Number 6 is effect on respiratory quotient. Respiratory quotient is the molar ratio of carbon dioxide production to oxygen consumption. Respiratory quotient in resting condition is 1 and during exercise it increased to 1.5 to 2. However, at the end of exercise the respiratory quotient reduced to 0.5. In this way, exercise effect on respiration.